Now we apply this Henry law to different applications here. I discussed one application for the scuba divers. You know what are scuba divers? Okay, which basically go deep down in the sea, right? With a cylinder on their back that is filled with some respiratory gas. They can respire in the sea. Now, in air, which gases we inhale for our normal respiration? Oxygen, only oxygen we respire, we inhale. If you just right now breathe in, which gases do you inhale? Oxygen, nitrogen. Oxygen is 20.95%, nitrogen is 78%, and remaining are like we have a carbon monoxide or carbon dioxide or argon or helium. All the gases are there in traces. So basically, we have one major gas, that is the N2 here, right? Getting me? One major gas is N2. That is solvent and oxygen is a solute here. So the scuba diver, that cylinder, that the scuba diver that is going inside the sea, what should that respiratory gas should contain? You tell me, which gases should I fill in the cylinder of the scuba diver? Oxygen plus nitrogen. Very good. But now, this mole fraction, if I talk about the oxygen nitrogen, its KH value is very, very less. So it has a high solubility. It means, suppose this is the, like I'm talking about, this is a sea here, right? And the scuba diver is here. This is a scuba diver, right? Floating somewhere. And this is the cylinder on its back, and this is the respiratory pipe here, right? It is respirating from here. So what will happen now, when it is inside the sea, when the scuba diver is inside the sea, what will happen, lot of nitrogen will be compressed in its lungs and the body. As long as the scuba diver remain in the sea, there is no problem. But when it comes up, what will happen? There is a lot of nitrogen in its body and the pressure outside is less. So what will happen? The nitrogen will come out from his muscles, all the blood vessels, from the high pressure to the low pressure. When it comes out, it will exert some pressure on the wall of the arteries and veins and muscles. It will cause a pain, lot of pain there, and that pain is medically called as a bend as a disease. And that pain due to the gases when it comes out. Yes, Amey. Yes, there is no any such heat produced or absorbed, no such observation, nothing like that. But only the point is, when the gas is coming out from the body in the form of the bubbles, that is exerting some force on the arteries and veins and muscles, force, it will cause some pain. So we don't use the nitrogen. We fill it with the helium. We fill with helium. 78% helium. Helium has a very, very low, very, very high KH value and less solubility. Now, Arjit, I'm coming to your question. Why don't we take oxygen only? Very good. You might have studied in your lower class, in somewhere in 11th class, that the rate of reaction is directly proportional to the concentration of the reactant, right? Concentration of reactant, right? So reactant here is the carbohydrate for the respiration I'm taking here and multiply by the oxygen. Now if I increase the concentration of oxygen, the rate of reaction will increase. If it is 100% oxygen, the rate of combustion will be very, very fast. And you know that so much fast that it will rise the body temperature to a very, very, very high temperature. It will cause like burning fever. Inside the body, it will start burning. So we don't take that pure oxygen. Even in air, nature has given us not pure oxygen. Nature has given us 20.95% oxygen. That is appropriate concentration for our normal respiration. I hope you're getting me. Everyone, why don't we take pure oxygen? Yes, aag lag jayegi. Yes, perfect. Now I got it. Right? Inside the body, a lot of heat will be produced. So please just read this through. The same thing I have explained. Just go through it. Soft drink and soda contain dissolved carbon dioxide, right? So the gas is filled inside that bottles or the cold drinks. Do you know why do we fill the carbon dioxide in the cold drinks? Anyone? Why do we fill? Anyone? Why do we compress carbon dioxide? Yes, very good. It is a preservative. Perfect. Helium has highest KH value, least solubility in the blood. That is why we take helium only. This point is clear. At higher altitude, perfect. Now, can you solve this question? We know from the Henry's law, partial pressure is equal to KH into mole fraction. So KH is equal to pressure upon mole fraction. And solubility is already given to you 0.195 molal. So molality means number of moles of solute upon mass of solvent, right? Solvent is water. So number of moles of water is equal to 55.5 mole. Till this point is clear? Then you can see mole fraction is equal to number of moles of H2S upon total number of moles. 195 is the number of moles. Dissolved 55.5. Put the value here and you get the answer 285. Very good. Who has given the right answer? One student who was reporting the same answer. Murli. Good. I hope everybody is getting question. Anybody having any doubt here? No doubt. Come to this question. Yes. Should I explain this question now? I think enough time I have given you. So what is given here is the KH value. See. And we have to calculate the quantity of carbon dioxide in 500 milliliter when pressure is 2.5. So pressure is equal to KH into mole fraction. This is the Henry law, right? So pressure is given to us, KH is given to us, we can find the mole fraction. And from the mole fraction, we can get the value of the weight. See? Like this, mole fraction is equal to number of moles upon total number of moles. So from here, I can get a number of moles. Student, are you getting me? Yes, students. I'm not getting any response from you. Fine. And once we get a number of moles, we can get the mass. because number of moles is equal to given weight upon molecular mass. Given weight upon molecular mass. So 1.833 grams is the correct answer. Any step that is not clear, let me know. I'm just explaining it once again. See the first page. Do you have any doubt? Arjit, I'm coming step by step. No doubt. From here, I have got the value of the mole fraction. And from the mole fraction, I can get the number of moles. Is there any doubt on this page? The simple formulas I'm using here. Yes, Arjit, but it is not clear here. Okay. Now, from the number of moles, I'm calculating the mass because we know that number of moles is equal to weight upon molecular mass. Pressure of water. Where I have used a pressure of water. Denominator number of moles water was there. Number of moles of water. See here. What is this number of moles here? Number of moles means weight upon molecular mass. How much water we are given here? 500 gram. Divide by 18. Weight upon molecular mass. This page is clear. First one is clear. On the second page, what's in doubt now? Okay, I hope you might be getting this thing. In case of dilute solution, I have neglected this value. Reason being, it is a dilute solution. Dilute solution means the amount of solute is very, very less. It is so less that this value is negligible as compared to this value. The number of moles of the carbon dioxide is very, very less as compared to number of moles of water. That is why I had neglected here. That is why I had neglected here. Yes, any doubt? All clear? Right. Okay, how do we know that it is dilute? Okay. Uh, how do we know that it is dilute? Generally, whenever we dissolve gases in any solvent, let it be water here, then the amount that get dissolved is very, very less normally as compared to the amount of water. You cannot have, like the carbon dioxide gas particles go inside the voids only, go inside the voids in the water only. And if you have 1 liter of water, or I have 500 grams of water, upon addition of the gas, does the volume increases? My question is very simple. Please answer this question, you'll get your answer. You'll get your answer only if you try to answer my question here. If I dissolve carbon dioxide in water, does the volume of the total solution increases? No. Right? Then where does the gas go? It goes into the voids. It goes into the voids. Are you getting me? It means the amount of the gas that we are dissolving is of not much value. Its weight is very, very less. Its amount is very, very less. And we can say it's a dilute solution, right? Yes, you are right, Venkata. We can take up in every problem a dilute solution. Yes. For the gases, they are very less amount of it is dissolved. Yes, you can neglect here in every problem. I hope now this question is clear. Everyone, fine. Student, are you understanding me? This topic and everything. This is very important topic for your examination point of view. And these questions are from the NCERT, your book. Even if it don't have gases also, we can consider it is dilute. Venkata, first of all, this question, this Henry law is applicable for gases only, right? Are you getting me? This Henry law is only for gases only. Fine. Now your question, if it is not a gas, it is something other question, right? Some other solution is there. Then if the amount of the gas is less than 5%, check there, amount of solute is less than 5%, then it is dilute, otherwise it is strong. Otherwise it is a concentrated one. Solve this question. So arrange this in the increasing order of the solubility. So you can take it as a multiple choice question also. Yes, Amay? You can consider this as a multiple choice question also. We have to arrange them in the increasing order of their solubility. 4 options are there. Give it the right option. Increasing order of their step solubility. It means lower solubility to the higher solubility. Increasing order. I don't want only one value. 1, 3. Okay, good. Yes, which concept are you applying? And one thing, yes, one thing very important. One more word is there. Anita, you are telling me that decreasing order. See your sign. This sign is a decreasing order. Anita, be very careful answering this question. You have to answer in increasing order. So you have to write like this only, not given the correct answer. Anita, getting me? This is the decreasing order, and you have to answer this in the increasing order. Yes, now lower the KH value, more the solubility. Absolutely correct concept. Yes, very good. Very good. So we can greater the KH value, less of the solubility. This concept has to be applied here. So helium, then nitrogen, then hydrogen, then oxygen. Venkata, absolutely correct. Good. So what is the difference between Rod's law versus Henry law? The phase test, Anita. I think check on the website which tests are there for you. Whatever the syllabus have been covered, that has been taught to you, only the multiple choice question or test will be there. That is your phase test, right? Aryan, check on the website. Everything is given. Everything is given. Date, time, syllabus. Everything is given, right? Amay is like he has explored everything. Good, Amay. Okay, fine. So Rod's law is applicable only under ideal condition, when Henry law is applicable under real or non-ideal conditions, right? And Henry law is applicable for liquid and liquid solutions, which one component is highly volatile, and gas in liquid solution where solubility of the gas is very, very low. Let me know if you find any problem in this page. It's a very, very simple thing that has been shown over here. No problem, right? Okay, simple things. Okay, leave this page. It's all rubbish things, simple things. Leave this. Fine. Wait. Okay, now let us solve this question. Okay, let us solve now. Enough time I have given you. See here, we are given here um, 20 milligrams of insulin dissolved in water diluted to 5 milliliter. It means we are given here WB is equal to 20 milligram, or I can say 20 into 10 to the power minus 3 grams. Diluted to 500 milliliter means volume is equal to 500 milliliter. Osmotic pressure is equal to 12.5 millimeter of mercury, and temperature is 300 Kelvin. Okay, quickly tell me the formula that we can use here. Pi is equal to, yes, CRT, right? C is molarity, weight upon molecular mass, into V into R into T. Now, what is the unit of, what are the values of R that you are going to use in this question? What is the value of the R you are going to use in this question? Yes, tell me. Yes, 0.0821. May also tell me, all of you, question to all of you, the unit of this value of R. What are the units of the value of the R for this value? No, liter atmosphere per Kelvin per mole. Liter atmosphere per Kelvin per mole. Getting me? It means the pressure value should be in atmosphere, volume should be in liter, temperature should be in Kelvin. So we are given here the volume in milliliter, so that should be now 10 to the power minus 3 liter. Is that clear? I have converted this into liter so that I can use this value of R. And the pressure should be in atmosphere, so I should convert this into atmosphere divided by 760. That will be equal to the value of the pressure in atmosphere. Temperature is already in the Kelvin, right? Per mole weight upon molecular mass, that will come out to be like this. Now you put all these values here and then solve it. If you're not converting these units, then you are just solving it but not accurately. So units have a lot of importance here. Are you getting me? Are everybody getting me? Good. So now see how I have done here. See, the pressure I have converted into atmosphere. Volume in liter I have been converting here. Arjit, once more. Okay. It is not a performance by any. Okay. Okay. See, what is to be seen once more means you need more clarity on the topic. Very important here. See, we are going to use this formula, right? Arjit, focus here, everybody. Once again, once more. This is the value of the R. So, which value of R to be used? which value of R to be used? This value. These are the units. So the volume should be in liter. So I have converted this into liter. Milliliter was given to us, so I converted into liter. Pressure should be in atmosphere wherever we are given the value in the millimeter of mercury. So I have converted this into atmosphere. I hope now it is very clear why I am doing it like this. Okay, fine. Then final answer goes like this. So how to find the accurate molecular mass, right? I told you the same question in the beginning. Why do we prefer osmotic pressure? Why do we prefer osmotic pressure rather than the elevation boiling point or depression freezing point or relative lowering vapor pressure? Reason being, the values are very small to be measured, too small to be measured. Magnitude is more in case of the osmotic pressure. Appreciable, the value is appreciable, can be liquefied easily, can be measured easily, right? And molarity is very small value. RT are quite significant to give the nice, reasonable bigger value of the osmotic pressure. And second reason I gave you that in the boiling or in freezing, what happens? In the boiling or freezing, what happens? The protein molecules, the biomolecules, they undergo dissociation or association, right? So they will not give the correct molecular mass. So what are the conditions for giving the accurate molecular mass? We'll be discussing now. The solute must be non-volatile, number one. The solution must be dilute and it should not undergo dissociation or association. Right? If it undergo dissociation or association, then the number of particles will change and the colligative property will change. In that case, we have to consider again the I factor. So these are the three conditions for getting the accurate value of the correct molecular mass. So sometimes the solid particle exhibit association or dissociation inside the solution due to intermolecular behavior. Due to this, the number of particles changes and the colligative property changes. That I have discussed here, that in some cases the dissociation takes place, in some cases association takes place. Let me know what happens if the solute undergo dissociation. If solute undergo dissociation, what happens? Okay, negative deviation is still left. Okay, yes. Let me cover that first. This already I have done, right? Okay. So number of particle will increase, colligative property will increase, and molecular mass will decrease, right? So that happens. Fine. One topic is left that student is saying negative deviation. Fine. Yes, thanks for reminding me. Let's understand here again the same topic, that is the negative deviation. Okay. Let us have a quick. Yes. So here I am drawing the Rod's law expression here, and it is a mole fraction of the A is equal to 0 and B is equal to 1. When it is A is equal to 1, means we have one component only, A. Here only B component, let it be PB naught. The graph goes like this. Are you getting me? This topic is, I think, very, very clear to you. This is the PB value is equal to mole fraction of B into PB naught. This point is very, very clear to you. Everybody? And this is the total pressure of the solution, that is equal to A plus B. Now, suppose I say I have a component A and a component B. A has AA interaction and B has BB interaction. Upon mixing, A and B interaction are developed, and this is a stronger interaction. This is a stronger interaction than AA or BB. If interaction is stronger, then the vapor pressure will be less or more. Vapor pressure will be less or more? Less. It means the graph goes like this. The vapor pressure decreases here. The vapor pressure decreases here, right? And the vapor pressure decreases for the solution also. So I can say the vapor pressure solution decreases. Number 1 point. Number 2, if the interaction is getting stronger, the heat will be released and delta H will be negative. If interaction becomes stronger, the particles come more closer and the delta V is also negative, means the volume decreases. 50 milliliter of the A and 50 milliliter of the B. After mixing, the total volume will be less than 100. Less than 100 milliliter. You know why? Because the particles have come closer. They have stronger interaction. Everybody clear? So this is the non-ideal solution showing negative deviation. Yes, are you clear? Yes, you reminded me this topic. Thank you. This topic was left. Are you there? Yes. Okay. Yes is not responding. No problem. Okay. Thank you. So this is the point. Right now, I have put a point here, a black color point on the solution line. This is the minimum vapor pressure of the solution as compared to other one. So corresponding to this composition here, composition here, this has the minimum vapor pressure. Thus the boiling point will be, complete my sentence, it has a minimum vapor pressure, the boiling point will be maximum. As the boiling point is maximum, it will give maximum boiling azeotrope. I may make one correction here. Maximum boiling azeotrope. What is azeotrope? What is azeotrope? Yes. What is azeotrope? Amay? Yes. Everyone, let me know what is azeotrope. Yeah, whose components cannot be separated, cannot be distilled by simple distillation. It behaves like a one pure liquid. It behaves like a one pure liquid. That is called an azeotrope. And at this particular concentration, where the vapor pressure is minimum, as compared to the A or B, the boiling point will be maximum. Boiling point will be maximum. So we call it the maximum boiling azeotrope. Right? Suppose I say A has a boiling point of 373 Kelvin, B has a boiling point of 387 Kelvin, but at the isotropic point, the boiling point will be greater than both of this. Let it be equal to 400 Kelvin. Am I clear? Fine. So now, student, am I clear what I have taught you in the last 4 classes of this chapter? Each and every concept is clear to you. So I taught you how to make ice cream. I taught you how to make aloo ka parotha. Yes. Okay. So I taught you many things, right? Okay. More very important thing. Coming to the apart from the top, like aloo ka parotha and ice cream and chai, like tea. Uh, you have to use the concepts in solving the numericals of the board level as well as for the competition levels, right? Only you have to use the same formula, same concept, you'll get through, right? Now, let me know any doubt, any question from throughout the chapter. I'll answer it right now. I'm waiting for your question. Let us play chemistry. Bat ball type. Okay, formality. Very good. Let us have a formality of teaching the formality. Really? Formality. Do you know the molarity? Yes. Do you know the molarity? Number of moles of solute dissolved in 1 liter of solution, right? And formality is the number of the formules, dissolved in 1 liter of solution. Now your question will be, what is formule? Now if I ask you, what is number of moles? What do you say? What is number of moles? Yes, tell me, what is number of moles? Given weight upon molecular mass, right? Very good. Similarly, number of the formules are equal to given weight upon formula mass. I am repeating here, formula mass. Now, what is formula mass? Do you know what is molecular mass? Do you know molecular mass? Yes. Suppose I ask you, what is the molecular mass of carbon dioxide, then you will say it is 44 grams per mole, because it exists as a molecule. Does NaCl exist as a molecule? Does NaCl exist as molecule? Yes or no? Make it very clear. Let us have yes or no. No. Arjit says no. Then in which form it exists? Venkata, if it is not molecule, then what is this? It's an ionic compound. Yes, it's a formula mass. It's a formula unit, right? It's a formula unit. Now, 58.5 grams. What is this? Is it a molecular mass of this compound or is it a formula mass of this compound? Amey, Yash, Arjit, let me know. What is this 58.5 for the sodium chloride? Is it a molecular mass or the formula mass? Arjit, it's a formula mass. It is not a molecule. Molecule have a molecular mass, Arjit. It's a formula mass. That's how we can get the formality. Otherwise, method of calculation of formality is same as the molarity. Only the units, only the concept is different, right? So that's why I was telling you, let us have a formality of understanding the formality. Got it? So students, that's all for today. Next class is on Monday at 7 p.m. and we will discuss about the chemical kinetics. Can you identify isotope from the mixture? Yes. Go through the content. You will be able to understand. Right. So that's all for today. Good night for today, and see you on Monday evening at 7 p.m. for the chemical kinetics. Thank you.